Have you ever seen ice that feels hot? It sounds strange, right? We know ice should be cold, but there's a fascinating scientific phenomenon called hot ice. It's a bit like magic, but it's real science at work. Hot ice isn't actually ice in the traditional sense. It doesn't form from freezing water. Instead, it involves a special ingredient called sodium acetate. This substance can create an amazing effect that looks and feels like ice, but with a surprising twist. It releases heat instead of cold. Imagine dipping your finger into a clear liquid. Suddenly the liquid turns solid, resembling ice right before your eyes. But here's the catch. It feels warm to the touch. That's the magic of hot ice. The key to understanding hot ice lies in grasping two scientific concepts: sodium acetate and supercooled liquids. Sodium acetate is a common chemical, often found in hand warmers. It has a unique property. It can hold a lot of heat energy. A supercooled liquid is a liquid cooled below its freezing point without turning solid. It's like tricking the liquid into staying liquid even when it should freeze. Think of it as a balancing act on the edge of freezing. Sodium acetate solution can become supercooled, and that's where the fun begins. When you introduce a trigger, like a small crystal of sodium acetate, to a supercooled solution, something amazing happens. The solution instantly crystallizes, releasing all that stored heat energy. This rapid crystallization is what creates the hot ice effect. Ready to create your own hot ice? It's easier than you might think. You'll only need a few common household items. Here's what you'll need: sodium acetate, distilled water, a saucepan, a stove or hot plate, a glass container, and a spoon or stirring rod. Follow these simple steps to make your own hot ice. First, dissolve the sodium acetate. In a saucepan, heat the distilled water. Slowly add sodium acetate to the hot water while stirring continuously. Keep adding sodium acetate until no more dissolves, creating a saturated solution. Next, cool the solution. Carefully pour the hot solution into a clean glass container. Allow it to cool to room temperature undisturbed. This creates the supercooled liquid. Finally, trigger the crystallization. Now for the fun part. Gently touch the surface of the cooled solution with a tiny amount of solid sodium acetate crystals. Watch in amazement as the solution instantly crystallizes, releasing heat and forming hot ice. The hot ice phenomenon isn't just a cool science experiment, it has practical applications too. Remember those hand warmers we talked about earlier? They often use sodium acetate. When you click the metal disc inside the hand warmer, it triggers the crystallization of the sodium acetate solution, generating heat. This principle can be applied to various heating pads and even some types of heat packs used in first aid. The ability to store and release heat on demand makes hot ice technology incredibly useful in everyday life. So the next time you encounter hot ice, remember that it's not magic, but a fascinating example of science at work. Stay tuned for more exciting science experiments and explanations in our upcoming articles.